Don't forget to hit the like and subscribe buttons. Hi there, in this video we identify components by testing them and making sure they are good for use. So firstly, we're looking at a resistor. Resistor being or having no polarity. You can identify the resistor by doing the color coding and working it out according to the color code chart, or put the colors into an app. In this case, if we suspect or know the value of the resistor, we can just make sure it does give that reading by doing a simple test. So my multimeter must be on the correct scale and on the correct setting, and so it doesn't matter which side my probe pins are with this component, and we will find the reading either way, whether we test turn the component around or test in a particular way on the legs. We found a reading there. In both instances the reading should be the same. It should almost be a 1 kilo ohm resistor. We've got 0.983. That's 1000 ohms. So that's a 1K resistor. Next up we have the capacitor, and it is designed in a particular way. These are polarity based capacitors. You see the top there has got a bit of a cut in the form of a plus, and that's simply that if it heats up, that it doesn't expand sideways and rather just open on top. It's got a short leg and a long leg. Short leg being the negative, and it can also be identified on the capacitor itself. You'll see there's a gray arrow, and in the gray arrow is a little minus. There we go, there's the minus. But that gray arrow or line also identify it as a minus, and that short leg is attached to that side. On the other side where the plus is nothing. There's no plus sign, it's just information. Alright, so if these legs are cut straight, you can still look at the capacitor and identify it as a capacitor being negative and positive. Now to test, our multimeter must be on the correct scale and on the correct setting where we can test for farads. So there I'll press the mode button, and we will see there on the screen we should get something like nanofarads. There we go, and it's on auto range. So the minute it picks up a reading, it'll give you a microfarad reading, whatever's on the screen, and the top will show little microfarads there in the icon area. And so in this case it doesn't matter where the red probe and the black probe goes. Even though it's a positive and a negative leg, you are still just doing a reading in farads. So doesn't matter if I turn it other way around, I would still get a reading. So to get a reading here closest to maybe 100 microfarads, also just keeping in mind that there's a tolerance involved here, same that with the resistor, that you would get either a little more or a little less, or approximately accurate value. So here the reading is going through, and we should get something close. Okay, 120 microfarads. And if I turn it the other way, we should technically get the same reading. All right, the reading should come up. You should just have patience. Also, the digital meters take little time versus analog, that where the needle would just jump up to the correct reading. All right, there we go. And that is your capacitor, simple design. The legs are slightly bent due to packaging, but that can just be straightened out for placement on the Vera board. And so as you can see there's this information there, and your value that you got on the screen should be close to the value it says that's on there. Right, for the next components, the diode family, Zener and LED. We will start with the normal standard diode, and you can see there these black ones identified with a little gray line in it. The legs are even both sides, but there's an anode and a cathode. And so here it is important to put when we test, to have the correct probes on the correct legs. The black probe or lead being in common, and the red one being in the positive part of the multimeter. Again, to identify, the bigger black part is the positive side of the diode. The side of the gray line would be the negative. So your black probe would be on the negative side, and the red probe for testing would be on the bigger black area. And again, we have to look at our multimeter. We're still not changing the knob, but we can see there is a setting for diode. So I'll hit the mode button, and then we will see on top there would be, press it a few times, and there we go, diode, and we're going to read voltage. All right. So again, if I don't get a reading in whichever way I put my leads, then this diode is not good for use, even if it comes from the packaging. So we need to identify and make sure that this diode can be used. And there we go, 0.564. So if I turn the leads around, I should not get a reading, or in this case, we turn the diode around, and there should be no reading. It would only give a reading if it is positive to positive and the black probe to negative, because you are activating that diode now to give that reading. It is actually being activated, it's switching. So in this case, the multimeter give it some volts, and that's what you're seeing happening across the poles or the legs. Next up is our Zener diode, and this diode will be tested in the very same manner as the diode before. This one is used for a slightly different purpose, and its symbol is also drawn slightly different. It's got two little ears almost at the ends of the diode sign or symbol. Again, this is almost like a reddish, pinkish, see-through material, and it's got a little black line. The black line indicating that that's the negative side of the diode, and the bigger part would be the positive side. So again, black probe or lead onto the negative side, and we get a reading 0.671. This diode is good for use. And again, just like we did with the other diode, we will not get a reading if the leads are the wrong way around. And this is also how we identify positive and negative of a diode. If the probes is put in properly into the multimeter, black being common, then we can, if we do not know with the physical identification, we can get the positive and negative by just using the test probes. So it's a nice way to identify as well. We will next look at the LED, light emitting diode, and it's got a particular design. There's a few ways to identify. It's got a long leg and a short leg. Unlike its the other diodes, this one must be also installed in a particular way, but it can be identified in various ways as to what's positive and negative. We've got a long leg, and the long leg is attached to a smaller plate in the actual material that gives off the light. And so If we look closer, we hold it up maybe into the sky. If you yourself can zoom into this video, you will see that a short pin, and that would be a positive pin. And then the shorter pin at the bottom, the leg, is attached to a bigger plate in the material itself. And that's how you identify. Let's say the legs is cut, you know, same size, you made a mistake. You can still identify positive and negative by just looking into the LED's material, because it's kind of see-through. Other LEDs made by different manufacturers would have another way of looking at where the negative is, and that's all you need to find, just either the positive or the negative, to identify it properly as to how to connect. That the negative will have a flat shaven area on the material itself, and so when you look at it from the bottom, you can see it's like flat. But this one is completely round, and there's enough information just looking at it to see where it's positive and negative. To test this, very interestingly, it is quite possible that this multimeter, by testing a voltage, we will leave it as on the same setting as before for the other diodes, and when we apply a voltage, which we will see on the meter, the light will actually light up. And this is also how we can see that this LED is good for use. Again, the short leg will have the black lead, and there we have 1.75 volts lighting the LED, and that's how much volts the LED needs to be lit. And so if I have the leads wrong way around, that LED will not light up. You will not get a reading, because again, with LEDs and with diodes, it is important to have the test leads on the correct legs to get a reading. If for any reason you didn't get a reading either way, then this LED is not good for use. Next up is a transistor. So there's many various transistors. This one is a little black one with a flat side. You can see there it's got 3 legs. You get the NPN and the PNP transistor, and then you get a MOSFET. This design is mostly NPN and PNP. This is a very small transistor, and you can see the front, as I call it, is flat, and the back would be round. I like to look at it from the front view or the flat view, and I would identify the first leg on the left to be collector, middle one base, and the far right emitter. Almost another way to say it, collector being input and emitter being output. So we have to also leave our multimeter on the same setting as for the diodes, because simply put, a transistor is a combination of 2 diodes, in this case with the NPN and PNP. And so I use a breadboard. It's the simplest way and the best way to actually test this, otherwise this thing will jump around on the surface. And so I should be able to get a voltage, so I will put the black lead on the base in the center, and if I don't get a reading, it probably is because the lead is on the wrong places. Now for a PNP or an NPN, it is very different. So in this case, if my negative is in the middle and I don't get a reading, then I should get a reading the other way around, with the red being in the middle. Here we go. That means it's negative, positive, negative. This is an NPN transistor. Can you see that? The red lead is in the center. So this is NPN. If I got a reading the first time around where the black lead was in the middle, then it would have been positive negative positive PNP transistor. So they both operate very differently, but that is how we identify a transistor. It is good for use because we did get the voltage readings on it. If we did not get the voltage readings, then this transistor would not be good for use. Alright, so that is far left collector, base in the middle, emitter on the far right. We've come to the end of this video. Thank you for watching. This video is brought to you by ProEngage. Don't forget to hit the like and subscribe buttons.